Hi students, welcome to Vari Medical Academy. So உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். Vari Medical Academy சார்பாக இனி வரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய faculty members லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் Vari Medical Academy சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க.
Welcome student. The topic is isomerism. Okay, so in organic chemistry the vast number of organic molecules are there, so we have to differentiate those molecules based on their properties and their existence of atoms and so on. Okay, so here the molecular formula or the molecules will have same molecular formula. Okay, so the organic compounds or organic molecules having same molecular formula, but it will differs with physical and chemical properties. Okay, the physical and chemical properties will be differed, but the molecular formula will be same. For example, the physical and chemical properties like boiling points and dipole moment and so on will be changed, melting point also. Okay, so this gives most and the numerous applications for organic compounds. So we are going to discuss about isomerism. Okay, so in simple words, isomerism is nothing but organic molecules having same molecular formula, but it will differ with physical and chemical properties. So this is very important word, physical and chemical properties. Okay, so this isomerism can be classified into two major sections. One is structural or constitutional, and next one is stereo. So structural isomerism or constitutional isomerisms are nothing but on the structure itself the placement of atoms will be differ. Okay, so this can be divided into 5 subsections. One is chain isomerism and position isomerism and functional group isomerism, metamerism, and last one is tautomerism. Okay, so these 5 isomerisms are structural isomerism. So these structural isomerisms are nothing but the groups will be and the atoms of the compounds will be differ. Okay, so the displacement of atoms will be witnessed in structural, so that's why we are calling that one as structural isomerism, in other words constitutional isomerism. Okay, and next one is stereo. So stereo means something called space. Okay, so the orientation of atoms in space 3D dimensional will be differ. So here the position or the displacement of atoms will be witnessed is here the position are in space. Okay, so 3D dimensional there will be difference in different places. Okay, so each can be classified into geometrical and optical. Okay, so these are all the main classification of isomerism. So structural isomerism is nothing but the compounds, organic molecules having same molecular formula, but the placement of atoms will be differ from each other. Okay, so those isomers are now known to be structural isomerism or constitutional isomerism, and stereoisms are nothing but in space the alignment of atoms will be different. Okay, so it is in spatial, so that's why we have mentioned spatial. Okay, so in space you have to imagine in 3D dimensional. Okay, so like Fisher projection, so when we deal about Fisher projection we have to change 3D to 2D. Okay, so there are numerous models to explain organic compounds, so those models in 3D dimensional can be based on stereo methodologies. Okay, so stereo is nothing but in space, so there is the different positions of atoms in space. Okay, that is stereo isomerism. So among this structural isomerism we have chain, positional, and functional group, metamerism, tautomerism. Okay, so chain isomerism, so the first one is chain isomerism. So the number of parent carbon will be different. Okay, so we will going to discuss brief again one more example. Okay, so first one is chain isomerism. Chain isomerism. Okay, so the number of parent carbon, the number of carbon atoms in parent carbon atoms in carbon skeleton will be differ. Okay, for example, CH3, CH2, CH2, CH3, right? So the molecule is N-butane. N-butane. How we can say this N-butane? Because there are 1, 2, 3, 4 carbon. So if the molecular formula of any hydrocarbon consisting 4 carbon, so the root word is but. Okay, so since all carbons are having single bond, so this is alkane, so N-butane. Okay, so for the example is CH3, CH2, CH, or else we can say see, so the chain is different. Here straight chain, but here there is less number of carbons in parent chain, only 3 carbons. Here 1, 2, 3, 4 carbons are there. Here only 1, 2, 3. The rest one will be in branch. Okay, so these isomers are nothing but chain isomerism. So the organic molecules will have different chains. Okay, so same molecular formula. So you consider C4H10. Okay, see, carbon are 4 atoms and hydrogens are here 5 and here 5, total H10. So similarly here also C4H10. So the molecular formula is same, right? C4H10, N-butane, but the chain is differ. So here normal, that is N-butane, here 2-methyl propane. Okay, 2-methyl propane, because in carbon skeleton parent chain the 3 carbon atoms are there. So if 3 carbon is there, so the root word is prop, so alkane, so it is propane. So the chain, the length of the chain is reduced, right? So here the length of the chain, if any organic molecules having same molecular formula but the length of the carbon chain is altered or differ, then that isomerism can be known as chain isomerism. Okay, so simple isomers, so you can easily solve based on these isomerism questions. Okay, so you can say like we can consider this one also N-butane, and okay, so here also 4 carbons, 1, 2, 3, 4, 1, 2, 3, 4, but the chain or ring is reduced. So in other words we can say ring isomerism also. So chain isomerism in cyclic, if there is no cyclic in hydrocarbons or these molecules, we can say chain isomerism. If it is witnessed in cyclic groups, then we can say that is ring isomerism. Okay, so ring isomerism and chain isomerism are both are same. So in aliphatic, like open chain compounds, the ring is reduced, open chain compounds, the number of the or length of the carbon chain is reduced, then that isomerism can be known as chain isomerism. So next one is ring isomerism. Similarly, so here branch unbranched, that is straight chain. Okay, where here it is cyclic, right? So here also same molecular formula. This is also C4H10, here also C4H10. Okay, so same molecular formula, but the ring is reduced, right? See, the ring is consisting 4 carbons, here only 3 carbons. So this is ring isomerism. In other words we can say ring isomerism. This is chain isomerism. Chain isomerism will be witnessed in straight chains, that is open cyclic open hydrocarbons. So ring isomerism will be witnessed in cyclic hydrocarbons. Okay, so both are same, don't get confused. So first one is chain isomerism and next one is ring isomerism. Both are same. If the isomerism witnessed in straight chain, that is chain isomerism. If the same isomerism is witnessed in cyclic groups, then that is ring isomerism. Okay, so the next one is positional isomerism. So next one is positional isomerism. So same molecular formula, the molecular formula of organic compounds will have same, but their position will be altered, the substituent of positions. Okay, so next one is positional isomerism. Positional isomerism. Okay, so the position of substituent or or else slash multiple bonds are functional group. So the compounds will have same molecular formula, but the position of the substituent, either substituent or multiple bonds or functional group, will be different. For example, CH3, CH2, CH2OH. So the molecular formula is C3H578O. Okay, so the molecular formula is C3H8O. See, C3CHOH CH3. Here also C, carbon is 3, 1, 2, 3. So the hydrogen is 3 plus 3, 6 and 7, 8. 8 O. But here see, so the oxygen OH group is attached with first carbon 2, 3. Whereas here 1, 2, 3. So the position of OH, that is alcohol functional group, right? So the alcohol functional group is attached first carbon in this compound, whereas that alcohol group is attached in second carbon. So the position is changed, right? Here first position, here second position. So this type of isomerism is known as positional isomerism. So you cannot say like the functional groups only will be altered in position, not like that. Substituent can also vary. For example, CH3, similarly we can have CH2Cl, here chlorine, okay, or else we can say any double bonds. So CH double bond CH2, here CH3 double bond CH and CH2 CH3. Okay, so 5, 6, 8, here is only 7, so it will not have CH3 CH double bond CH CH3, and next one is CH2 double bond CH CH2 CH3. Okay, so here 1 2 3 4 8. Here we have 1 2 3 4 5 6 7 8. Okay, so the molecular formula is C4H8. Here C4H8. See, here the double bond, multiple bond is placed in 1 2 3 4. Here 1 2 3 4. So the double bond is placed in second carbon. Here the double bond placed in first carbon. So the position of multiple bond is changed, right? So this sort of isomerism can be known as positional isomerism. Okay. Okay. So what is the name of the compound? This one, 1-propanol. Okay. Since the OH group, hydroxy group, that is alcoholic OH group, is attached to first carbon, so we can say 1-propanol or propane 1-hal. Okay. So this compound is, the OH group is attached in second carbon, so we can say 2-propanol. Okay. Both are same molecular form. C3, what is the molecular formula, students? C3H578O, C3H8O. The molecular formula of these two compounds are same, C3H8O, but this one is 1-propanol and this one is 2-propanol, because the OH group, alcoholic OH group, is attached with first carbon. Here that OH group is attached with second carbon, so the position of functional group is changed, right? So the position of functional group is changed, so that type of isomerism can be said to be functional positional isomerism. Okay, so here we have one more example. See, so the molecular formula of these two alkenes are C4H8, but the double bond is placed in second carbon, between second carbon and third carbon, here first and second carbon. So the place of double bond, the position of double bond is changed. So this is also one of the type of positional isomerism. And next one is functional group isomerism. And next one is functional group isomerism. So these topics are very simple. Okay, you can easily get marks in this type of concept, so you can easily understand also. So try to understand more. Okay, so next one is functional group isomerism. Functional group isomerism. Okay, the functionals, the molecular formula will be same. Molecular formula will be same, but functional groups are different. Functional groups are different. What is the example? So CH3, CH2, OH. What is the molecular formula? C2H6O, right? So this is alcohol, right? And next one is CH3 double bond CH3. Okay, so it will not be like that. We can say oxygen. Okay, so this one C2H6O. Both are same molecular formula, right? Both has same molecular formula, that is C2H6 and O. Okay, same molecular formula, but the functional groups here alcohol, and whereas here ethers. What is ethers? Okay, so same molecular formula, but the functional groups are different. Okay, so the type of group isomerisms can be named as functional group isomerism. Okay, so it is very easy, right? So first one is alcohol and next one is ether. So same molecular formula, but functional groups are different. Okay, so this is functional group isomerism. Okay, so next example we can discuss in CH3, CH2, COO, H. Okay, next one is CH3, COO, CH3. Okay, see the molecular formula is C3H6O2, right? Here C3H6O2, but the functional groups are different. Here carboxylic acid, right? Here esters. What? Esters. Okay, so R, C double bond O, OR. So this is ester. Here R, COOH is carboxylic group. Okay, so this is functional group isomerism. Okay, so next one is metamerism. Okay, so the molecules are having same molecular formula, but a polyvalent atom will be there. Okay, so oxygen is polyvalent, so the valency of oxygen is -2. Okay, so the sides of polyvalent atom will be differ. See here there are two carbons are there. Here 2 carbon and here 2 carbon. Here only 1 carbon is there and next is 3 carbon. So the sides of polyvalent atom will be differ to each other. So one is ethyl group and next one is ethyl group. Here methyl and propyl. Okay, so this set of isomerism is known to be metamerism. Okay, so metamerism is nothing but the molecules will have same molecular formula, but in polyvalent atom the sides will be differ. Okay, last year Neet question also the same one, so it is very important. Okay, so this name is ethoxyethane. So molecular formula will be C4H10O. Okay, here C4H10O, same molecular formula. See, both are same, but their sides are different in between polyvalent atom. So we can change this oxygen with sulfur also. Okay, we can change sulfur also because sulfur also polyvalent atom. So this type of isomerism is known to be metamerism. Meta means in between. Okay, so in between our sides of polyvalent atom will be differ. So one is ethyl and here also ethyl, but here one is methyl and next one is propyl. So same molecular formula but sides. So here the side we can say like this methyl group has rearranged to this side. Okay, so that's why one carbon is reduced and here one carbon is increased. 3 carbon, here 1 carbon, here both are having to each other. Okay, so the side are differed. Okay, so this isomerism is metamerism. Okay, so next one is tautomerism. Tautomerism, which is also very important one. Again the molecules will have same molecular formula. Molecules will have same molecular formula. Molecular formula, but their existence will be different, in dynamic equilibrium. So first you have to understand what is dynamic equilibrium. Equilibrium is nothing but, so the rate of forward reaction, that is this one, and rate of backward reaction, both are same, so we can say that is equilibrium. So here A is equilibrium with B. Okay, so this is equilibrium. So this word dynamic, so dynamic means it will be changed. For example, the concentration of A is increased now, so next the forward reaction will be maximized, because then only we can get the equilibrium. So it is something is dynamic, so the concentration or rate of the reaction will be dynamics. That's why we can say the molecules should have same molecular formula, but their existence means the form of existence will be different in dynamic equilibrium. Okay, so this word is very important one, dynamic equilibrium. Dynamic equilibrium is nothing but, so if any factors are affecting this equilibrium, then it has to regain, that is dynamic equilibrium. Okay, for example, we have CH3 and C double bond O CH3. So what is this molecule? Acetone, right? Acetone. Since it is C double bond O, ketone, the functional group is ketone, so it has been dynamically equilibrium with CH2 double bond C OH and CH3. See, the both are having same molecular formula, carbon 3 and hydrogen 6 and oxygen 1. Here also 3 carbons, 6 hydrogens, 1 oxygen. So same molecular formula, right? Same molecular formula, but their existence here keto form, here keto. C double bond O is nothing but keto group. Okay, here double bond ene, so that is alkene plus alcohol, so alkene plus alcohol gives enol. Okay, so their existence here keto form, here enol form. How we can obtain this keto enol form? Okay, so this is the same type. Next one we are going to see how we can say the ketone and enol form will be exist. Okay, so this one, see, so carbon is double bond with oxygen, so electromagnetic effect or polarization of double bond is taking place. So oxygen is more electronegative than carbon, so it has to pull that electron towards itself. So oxygen will have partially negative charge and carbon will be changed to positive charge. So to stabilize this carbocation, so this bond, so this is hyperconjugation, right? So this sigma bond has to come here and this hydrogen goes with oxygen. So if this bond comes to here, we have double bond, right? Here resulted double bond and this hydrogen moves to, or migration is taking place to oxygen. So this is OH. So here keto form is there and here enol. Okay, how we can say this is enol? Enol means en, that is double bond alkene, plus alcohol OL, so which gives enol. Okay, so their existence is different. So here keto form, here enol form, but same molecular formula, but in dynamic equilibrium their form is different. Okay, so this isomerism is known to be tautomerism. So in other examples, in nitro acinitro form, okay, nitro and acinitro both are tautomers. CH3 N double bond O and O minus. Okay, this is nitro group. CH2N so this one is acinitro. This is acinitro form. This is nitro. See, so when the hydrogen is placed in next to electron withdrawing group, that hydrogen is acidic hydrogen. Okay, so this hydrogen is, in other words, acidic hydrogen. So when the polarization takes place, so this will have minus and plus, so this hydrogen has to go with here and one double bond will be created. Okay, so this hydrogen is going to oxygen with oxygen, so this bond will be changed to here, so we have acinitro form. So this one is nitro form, this one is acinitro form. Okay, so there will be no change in molecular formula, but their existence is different in dynamic equilibrium. Okay, so this is tautomerism. Okay, so two examples we have discussed, both of them is very important one, nitro and acinitro, keto and enol. In very many reaction we will going to see keto, enol, tautomerism, nitro, acinitro, tautomerism, both are very important one. The chemical property of nitromethane and acinitro form will be differ. Okay, so the main property is molecular formula will be same, but their properties in physical and chemical will be differ. Okay, so the formula is both are same, C3 or C1H3NO2, here CH3NO2, both having same molecular formula, but their structures are different in dynamic equilibrium. Okay, so next configurational isomerism, that is stereo isomerism we are going to discuss, where geometrical isomerism and optical isomerism. So next class we are going to discuss that one. Okay, so thank you.